Thank you, sir. Thank you to the organizing committee and everyone present here for this wonderful opportunity. I am Pawan. I represent Thermax Limited. Uh, so, as we all know, Thermax is a renowned name in a lot of process cooling and heating applications. We also deal in clean air and clean energy. Uh, the topic that I am going to be discussing today relates to the energy transition in chemicals. So Thermax has now positioned ourselves as a partner of energy transition, enabling our customers to transition from fossil-based energy to reliable electrical energy or a renewable source of energy. So this is something about Thermax. I will not go into much detail. So the current subject matter that I'm going to represent is about cooling. So I represent Thermax's cooling division for the sales in the Gujarat and Madhya Pradesh region. So to achieve decarbonization or to move in this journey of energy transition, we have a couple of solutions that I'll be discussing today. There is a lot of low-grade waste heat energy available in almost all the process industries, which includes chemical industry, which is at the focus for this event. So in our product basket, we have heating and cooling applications for which there is a need for decarbonization. So the current method is, of course, heating through fired boilers, through fired heaters, utilizing fossil fuels such as either coal or natural gas or HSD. What we are trying to do here is utilize low-grade energy available in the process to generate heating and cooling. So for this, we have two particular technologies available with us today in the cooling portfolio. The first one is vapor absorption technology. It's a 100-year-old technology. Thermax has now pioneered this, and we have been manufacturing vapor absorption chillers for almost 40 years now. We have our in-house R&D department, and we have installed base of around 7,500 plus chillers, vapor absorption chillers. I'm sure most of you would have used or come across this technology in the process industry. So in the vapor absorption technology, we have chillers, of course, and an altered version of a chiller is also an absorption heat pump. So as we all know, a chiller will deliver chilled water as a process utility, and a heat pump, which is now gaining a lot of traction as a product, as a solution for decarbonization, produces chilled hot water as a utility, right? So we have that in our basket. And along with this, we have vapor compression technology. Of course, all of us are aware about the vapor compression refrigeration cycle, which we have gone through in our engineering days. So we have repurposed these two technologies, that is vapor absorption and vapor compression, to generate hot water, chilled water, or a combination of both. So this is just a broad classification of what Thermax has to offer for this kind of process heating and cooling solution. Moving on, we talk a lot about heat pump these days, right? It's a buzzword now to achieve your decarbonization goals. So what is it exactly? So as I mentioned, heat pump is a tool to deliver hot water. As we all know, most of the process heating applications can be done through 90 degrees of process heating. But to achieve that 90 degree, we have to fire a boiler, generate steam at around 10.5 bar or more, send it to the process, and then generate that 90 degree hot water or heating application. So the scheme that is in front of the screen right now is the conventional process. Let's say steam goes in or a fuel-fired energy goes in and hot water comes out. So it's a 1:1 heat transfer ratio. Whatever energy the steam loses, hot water gains and then moves ahead. What we have to offer is a heat pump solution which introduces a third kind of energy. So apart from steam, or in any case, it is fuel, which is generating hot water directly. So apart from this main driving source of energy, we utilize another source of energy, which is waste heat available at the process industry. Ye waste heat can be available in the form of, let's say, hot, chilled water or cooling water or any kind of process waste heat water. So by introducing this third energy, what we are trying to do is reduce the main energy, the main source of energy, which was originally targeted to achieve that hot water application. So from our estimates and the installed base at site, we're able to reduce around 40% of the main heat source. It can be steam, it can be direct fuel, or it can be electricity. So whatever you are currently utilizing to generate that hot water, we can do it at 40% less cost, while also generating chilled water or cooling as an incidental or a byproduct. Right? So since this event is targeted for chemical industry, we have listed down some of the applications that we have worked for in the chemical industry. So the first and the pioneered product which Thermax has to offer is the absorption chiller. To generate chilled water, we can utilize any kind of process waste heat available. The second point, we can condense any vapor, any process waste heat vapor. It can be condensed, used as a heat source in a VAM chiller to generate chilled water. And we can also use solvent, which has anyway to be cooled. We can utilize that energy in a vapor absorption chiller to generate chilled water. So whatever cooling capacity a vapor absorption chiller delivers, it directly reduces the load on your electrical chiller, hence giving you carbon footprint reduction. So this is about absorption chillers. For hot water generation, we run heat pumps. So we have waste heat or whatever waste heat available, be it cooling water, be it process waste heat, or chilled water as a waste heat. So we'll cool down that water for you, generate hot water in return, while also giving you 40% of energy savings. This will also reduce your dependency on direct steam. So if your plant is short on steam, you are bound to go in a expansion mode. Your boiler does not allow you to expand. You can utilize these methods, save some steam for your process expansion while generating the same amount of hot water. The third solution that we offer is of the process cooling solution. So in comparison to open type cooling towers, which are normally used in all kinds of industry, in comparison to those, we offer closed loop cooling tower solutions. तो ये closed loop वहाँ पे काम आएगा जहाँ पे you cannot afford any kind of contamination. So the process fluid will remain inside the tubes. It will lose its heat, but will not interact with the atmosphere or the spray water. So this will eliminate all your worries about contamination, and it can replace the cooling water plus PHE, normal open type cooling tower plus PHE का जो application है, उसको हम सीधा replace करके closed loop cooling tower लगा सकते हैं. So if I talk about vapor absorption as a technology, which we have pioneered, and we're talking about waste heat, which has to be utilized in your furtherance of goal of decarbonization, we can use steam, which is available in the process as low as 0 bar gauge. 100 degree का steam होगा, we are able to use it as heat source. If you add any kind of waste water, hot water at temperatures as low as 60 degrees Celsius, I'm sure most of us recover heat from compressors, right? And a lot of reactors also generate hot water to take the heat away from the reactor. So we can use hot water as low as 60 degrees as a heat source in a vapor absorption chiller to give you required amount of chilled water. Recovered waste heat, as I mentioned, if it isn't available in form of flue gases, let's say you have a furnace and you are exiting that furnace gases at, let's say, 250, 300 degrees Celsius, we can utilize those, exchange its energy in the chiller, and give you free chilled water. Even compressor waste heat recovery can also be done. We have done similar projects for 1000 CFM compressors and above. Process induced waste, as I mentioned, any kind of vapor available at site can be utilized if it is of a suitable temperature for an absorption chiller. And of course, renewable energy. So on the left hand side, you can see the multiple gambit of options available for waste heat energy available. And on the right hand side, we can give you combination of chilled water, hot water, or both simultaneously. So this is about a chemical major in India, wherein we have given an absorption chiller. So the challenge that the customer was facing is their electricity costs were high. They also had a boiler. So we did an OpEx analysis and we found that running an absorption chiller was cheaper than running a vapor compression chiller. And the steam was available as a waste heat, from an induced waste heat steam source. So we harnessed that energy into absorption chiller and we reduced their dependence on electrical chillers. Talking about numbers, they experienced around 55% reduction in electricity cost. So these are the products. So coming from chilled water to hot water, these are the products that are available in our basket when it comes to hot water generation. So we have absorption heat pumps. Of course, as the name suggests, absorption will run on steam as a driving source. It can generate hot water up to 110 degrees Celsius, while also giving you energy savings of around 40%. If the steam is costlier and you have renewable energy available with you, nowadays a lot of companies are going for renewable energy such as wind, solar, or a combination. So we can offer electrical heat pumps to generate hot water up to 120 degrees Celsius. I'm sure most of the process heating applications can be catered through this. A 120 degrees Celsius hot water will eliminate combustion altogether. So that is what we are trying to do. So this will also eliminate the issues that come with boiler operation, the regulatory norms, the compliances that you have to follow. All these can be done away with if we opt for an electrical heat pump. And we have merged these two technologies. If the economies allow, we can offer a hybrid heat pump as well. So this takes in steam as well as electricity to generate hot water up to 120 degrees Celsius. So there can be combination of these, or any of these can be suitable based on the energy prices and the power prices available at each of the industry. Again, coming to the Gujarat's chemical scenario, we have installed a hybrid heat pump. I am proud to announce that this is installed in our own Thermax chemical factory in Jagadia. It is now under commissioning and will soon be ready for showing to any of interested clients. So this was the problem statement. They had a biomass-fired boiler, but still the costs were running high, and the requirement of hot water was being met through steam generated from a biomass boiler. So we given them a heat pump to generate hot water up to 110 degrees Celsius. It has replaced the traditional steam-based heating to a certain extent, giving them savings and also reducing their dependency on boiler. The result, they are saving around 3,000 tons per annum of steam, and water is also being saved at around 2,000 meter cube per annum. Why water is being saved? Because chilling is an incidental benefit here. Along with hot water, a heat pump will also give you cold water or chilled water as a benefit. So whatever water, let's say cooling water goes into producing that amount of chilled water is also saved because it's free of cost in a heat pump. The result, their OpEx was reduced by 52 lakhs per annum just by installing this. So these are the projected savings. The unit is under commissioning and will be operational by the end of next month. This is the live actual picture of this unit. So apart from hot water and chilled water, we also have process cooling solutions. Standard जो solution है process cooling के लिए, that is cooling water operated through a cooling tower. उसमें आप जानते हैं कि there is a lot of evaporation losses, there is blow down losses, there is drift losses which have to be made up. Water itself is a cost and you are also spending energy. There are already solutions in place which can replace such kind of evaporation cooling through adiabatic terms or through air cooling. That technology is already in place, but it comes at the cost of higher power consumption. So we have this hybrid mode which can operate on both wet and dry cooling, giving around 40% reduction in overall evaporation losses. This is one of the case studies. And then for chemical, we have are steam accessories. The product are in your in the slide. So one standout product which is HPCRS, that is high pressure condensate recovery system. Of course, all of the other are known, that is PRS or PRDSH, but high pressure condensate recovery system recovers the high pressure condensate directly from the process to the boiler, hence eliminating all kinds of losses that are going into the way. This is our product installation base for steam accessories. That is all the time I have. Thank you.